Welcome class to this lesson on capacitors in DC circuits. So the purpose of a capacitor in a circuit is to store charge. So in this lesson, we're going to be looking at a series networks for capacitors in DC circuits and parallel networks for capacitors in DC circuits. So we'll start with a series network. So for capacitors connected in series, so this is the symbol of a capacitor. So this is capacitor 1, which is C1. Then we have another capacitor, which is a C2, and we have another capacitor, which is a C3. So the SI unit for capacitance is Faradays, but it's too large for regular values. So normally we work with microfarads. So here it's going to have 4 microfarads. Then this is going to have micro. This is going to have 2 micro. So for us to calculate the total capacitance of this circuit, we have to bear in mind that the way we work capacitance is opposite to the way we work resistance. So for capacitors in series, we use the formula for resistors in parallel. So to calculate the total capacitance, we have to say 1 over CT is equals to 1 over C1 plus 1 over C2 plus 1 over C3. Then let's substitute values. So 1 over CT is equals to 1 over C1. The value of C1 is 4. It's 1 over 4 microfarads, but we don't have to put units in the calculations. We just put the units at the end. Then plus a 1 over C2, which is 1 over 6. Then plus 1 over C3, which is 1 over 2. So here what we do, we look for a common denominator, isn't it? So for the denominators 4, 6, and 2, our lowest common multiple here, our lowest common denominator is 12. 4 goes 3 times into 12. 3 times 1 is just 3. 6 goes 2 times into 12. 2 times 1 is 2. 2 goes 6 times into 12. 6 times 1, just 6. Then so it's 1 over CT is equals to 3 plus 2 plus 6. That's 9, that's 11, isn't it? 11 over 12. Then for us to find the capacitance, we have to invert both sides, isn't it? So if we invert the left-hand side, we get CT over 1 being equivalent to 12 over 11. So the total capacitance CT is going to be equivalent to 12 divided by 11. So the total capacitance is going to be 1.09 microfarads. Let's move on to capacitors in parallel. So for capacitors in parallel, it's similar to resistance in series. So the formula for capacitors in parallel is going to be CT is equals to C1 plus C2 plus C3. So CT is equals to C1, which is 4, plus C2, which is 6, plus C3, which is 2. So the total capacitance is going to be 12 microfarads. So that brings us to the end of this section on capacitors in DC networks. As we always say, like, share, and subscribe. So to get full information on this topic and all the other topics in electrical trade theory, kindly like, share, and subscribe. So to get full understanding on this topic and all the other topics that we are doing, kindly download textbooks and past papers in the description link below. See you next time.